Now we will discuss how to find the inverse DTFT of the signal x of e raised to j omega, which is equal to 1 for modulus of omega less than or equal to w, and 0 for w less than modulus of omega less than pi. And in this question, we need to find out x of n, because x of e raised to j omega is already given. So now we need to find out x of n. We'll see how to find out the inverse DTFT. So this is the transform pairs. This is the general formula for calculating DTFT, that is x of e raised to j omega. By using this formula, you will get x of e raised to j omega. Now we need to calculate, or we need to find out what is x of n. X of e raised to j omega is already given. So we need to use the inverse DTFT formula, because we need to find out x of n. Inverse DTFT means we need to find out x of n. X of e raised to j omega is given, and we know that x of e raised to j omega is a periodic function. So we need to find the inverse only in the limit minus pi to pi. Now we will look at the signal. What is the shape of the signal? From the formula, it is given modulus of omega is less than or equal to w, means minus w less than or equal to, minus omega less than or equal to w, and one more condition, omega less than or equal to w. That's the meaning of modulus. We need to take both the cases. If it is minus omega or plus omega, it is less than or equal to w. Now we can rearrange this. This is actually minus omega. We can write in terms of omega. If we want to write in terms of omega, we need to multiply with minus 1. So this becomes omega and w becomes minus w. So at the same time, we need to reverse the sign also. So we can rewrite this minus omega less than or equal to w like this: omega greater than or equal to minus w, and the other condition is C, which is omega less than or equal to w. So we got two conditions, that is omega greater than or equal to minus w and omega less than or equal to w. Now we can plot this waveform. So this is the limit minus pi to pi, because it's a periodic function. X of e raised to j omega or DTFT is a periodic function. It's from minus pi to pi. And in this question, we got omega, that is omega is greater than or equal to minus w. So this is minus w and this is plus w, and it is less than omega. So I can plot this waveform, and whose magnitude is 1 from minus w to plus w, means the signal x is from minus w to w. That's the meaning of modulus of omega less than or equal to w. And we can check the other case also. Here you can see omega or modulus of omega is between w and pi. We'll see what's the meaning of that. W less than or equal to omega less than pi, or we'll take this case. And similarly, we need to take one more case, w less than minus omega less than pi. If you want to change this minus omega to plus omega, we need to multiply with minus 1. So the now equation becomes like this: minus w greater than omega greater than minus pi. So during this interval, or w less than modulus of omega less than pi, the same thing is written here. For this region, the function magnitude is 0. So we can see that from minus pi to minus omega, minus pi minus omega, it's 0, and also from w to pi, the w to pi, in this region also the function magnitude is 0. Now we can evaluate the signal. X of n is equal to 1 by 2 pi integral minus pi to pi becomes minus w to w. X of e raised to omega is 1 into e raised to j omega n, and the variable is d omega. So we got the equation. Now we need to simplify this. We need to find the integral of the signal. So again, 1 by 2 pi. If you integrate this, e raised to j omega n, omega is the variable, so this j and n will be considered as a constant. So we can write e raised to j omega n, and omega is the variable, so this j n is considered as a constant, and we need to apply the limit. Lower limit is minus w and upper limit is w. Now we can apply the limit. 1 by 2 pi jn, also we can write e raised to j, in place of omega you can write w, wn minus e raised to minus j wn. So this is the equation we got, and we know the basic equation for sin theta and cos theta. This is a formula. So cos theta, you can write e raised to j theta plus, now it is written in minus, so it will be sin theta. So for that you need 2 and j, so we can group this 2 and j, e raised to j wn minus e raised to minus j wn. So your final answer will be like this: 1 by pi n sin w n, and again you can group these two terms, sin wn and wn. So for that we required, you can write this term in terms of sync. For that we need to write one more term is missing here, wn is here, so we need w here. So you can multiply with w both at numerator and denominator. So you can write w divided by pi sin wn divided by wn, and this term you can write it as a sync. So it becomes w by pi sync wn. So this will be your final answer, and the waveform will be like this. So this is a sync function. So this is the shape of sync function. Now we will discuss another question, which is to find out the inverse DTFT of a signal x of e raised to j omega is given by e raised to minus j omega for the limit minus pi to pi. So x of e raised to j omega is a periodic function. Period is 2 pi. So the signal is defined over one period, 2 pi, minus pi to pi. Now in order to find out the inverse DTFT, this is a general formula, and this is x of e raised to j omega, that is the formula to find out DTFT, and we need to find out inverse DTFT, that is a signal x of n. So it's 1 by 2 pi integral minus pi to pi x of e raised to j omega e raised to j omega. In this question this is direct. The signal x of e raised to j omega is defined from minus pi to pi only for one limit. So we can directly substitute here minus pi to pi. So we can write the equation, and we need to use this formula because we need to find out x of n. So x of n is equal to 1 by 2 pi for the limit minus pi to pi. The signal is e raised to minus j omega, and x of e raised to j omega we substituted e raised to minus j omega. Now we need to write the next term, e raised to j omega n. So e raised to j omega n, and the variable is d omega. Now we can group these two terms. So you can write 1 by 2 pi integral minus pi to pi and e raised to j n minus 1 into omega d omega. Now we can write, or we can integrate this. So again 1 by 2 pi, here the variable is omega, so this j n minus 1 will be the constant. So e raised to j n minus 1 into omega divided by j n minus 1. The limit is from minus pi to pi. Again apply the limit 1 by 2 pi j n minus 1 into e raised to j n minus 1 pi minus e raised to minus j n minus 1 into pi. Now we can write the standard equation. Here it is minus and 2g, so you can write in terms of sign. So equation becomes 1 by pi, the remaining term is sine pi n minus 1 by n minus 1. So the other terms 2 and j we can group with this term, so that's why it is written as sine pi n minus 1. So remaining is sine pi n minus 1 divided by pi n minus 1. So we can write this in terms of sinc. So the final answer is 1 by, we can write as in terms of sinc pi n minus 1. So this is the final answer.